Morning, everyone. So today we are going to continue learning chapter 9, but I didn't like the order of the textbook, so I'm going to jump to section 6. Because I feel like solving rational equations is the next logical step in the progression after adding, subtracting, multiplying, and dividing. Because that's what we did. Friday we multiplied and divided. Yesterday we added and subtracted. And I say now that we know how to do all that, we set them equal to things, and we actually solve for x. Cool with that idea? We will come back and we'll do sections 3, 4, and 5. And I believe there's a section 7, but we'll come back, okay? So it's not that it's not happening, it's just not happening yet because I did not like the order. Let's talk about fractions. I've said it to you, I don't know, 3 bazillion times this year. Do you like fractions? And the answer is always no. And then I say, so how do we get rid of them? How do we get rid of fractions? Somebody tell me. Like, let's say I had this. Well, that if you multiply by the reciprocal, you're going to get a 1, but that just creates a fraction elsewhere. Like, how would I make it so that I don't have fractions? Yes?
Multiply it by its denominator.
Yeah, you just multiply by the denominator. So we could distribute a 2 across this entire equation, and we would get x plus 8 equals 10, and we have our answer. Clearly, x is 2, but who cares? I don't care about the solution. My point is, you all know that if you don't want to look at fractions, all you have to do is distribute your denominator, and you'll have no fractions, right? Just because the math looks different does not mean the math changes. Whoop. One denominator. Easy. One denominator, easy. Multiple denominators, crap. All right. So what if I changed it? What if it said this? I don't know. Now what? If I distribute a 2, this fraction's gone. But this one's not. Well, if you have a fraction equal a fraction, you'll cross multiply, yes. But we don't have that situation. What you're talking about solves a proportion, and you do have something like that in your homework. I think it's question number 3. But we don't cross multiply when we have multiple on one side. So like I said, distributing the 2 would get rid of this fraction. You'd have 2x plus 8 over 3 equals 10. Then what would you need to do? You'd still have a fraction. Then what would you need to do? Distribute the 3. So if you wanted to do that in 2 steps, be my guest. I'm a much bigger fan of doing it in 1 step. Yesterday we added and subtracted fractions. What's necessary in order to combine those to a single fraction? The least common denominator. What is the least common denominator? 6. Guess what? If you distribute a 6 across everything and reduce, you'll have no fractions. Basically, what I'm getting at is, if you would like to get rid of all of your fractions in 1 step, find the least common denominator, which we practiced yesterday, distribute the least common denominator. And if you did that right, you will have no more fractions. And then we could just solve for x the way we're used to. Cool with that? All right. For example, in this one, if you did decide to distribute a 6, you'd get 3x plus 8 equals 30. You would subtract 8, you get 3x equals 22, and you would get x equals 22 over 3 solved. Okay? But what happens when they get a little bit more complicated is the question. Like, what happens when they're rational functions? They have x's in the denominator. So everything changes? No. Just because the math looks different doesn't mean it is different. Math doesn't change. We always follow the same rules. You want to get rid of the fractions that you see here? There's only one. You would distribute the least common denominator. There's only one. Obviously, that least common denominator is x. So that's what we're going to do. Distribute an x across the entire equation. I will draw the distribution lines. I'm not going to lie, the second question gets a little big on the space, so we'll write a little bit smaller on that one. For this one, when you distribute your x, what you're going to get is x squared plus 3x over x equals 4x. At this point, I had more than one person in period 1 want to know why I wasn't distributing the x to the top and the bottom of the fraction. If you distribute an x to the top and the bottom of a fraction, all you've done is multiply it by 1, and that will not get rid of the denominator. If I multiply the top and bottom of this by x, it gets me 3x over x squared, which reduces to 3 over x, and you've done nothing. Pretend this is x over 1, and you're multiplying two fractions, which means multiply across the top, multiply across the bottom. Okay? So you're getting 3 times x and x times 1, because we're saying this is over 1. So we only distribute to the tops of fractions. You guys cool with that idea? All right, great. Those x's cancel, and like I said, if you do it correctly, you will no longer have a fraction. Instead, you just have a quadratic. And we've practiced solving quadratics a lot. Bring it all to one side because it's not in vertex form. If it was in vertex form, you'd use SADMAP, but it's not in vertex form, so you're going to bring it all to one side, and we are going to hope that we can solve by factoring. Subtract 4x from both sides. And are there two numbers that multiply to positive 3 and add to negative 4? Negative 1 and negative 3. Absolutely. Since there's no number in front of x squared, I can just write x minus 1 and x minus 3. If there was a number in front of x squared, you would have to use a different method for factoring, but still. And now that we have it here, you just set your parts equal to 0, and you can see that x equals 1. Because of x minus 1 is 0, you add 1 to both sides, you get x equals 1. And x equals 3. Because of x minus 3 equals 0, you add 3 to both sides, and you get x all alone, x equals 3. The very last thing that you must always do is check for extraneous solutions. We've had to do that a few times this year. We had to check for extraneous solutions when we were solving absolute value equations. We had to check for extraneous solutions when we were solving logarithmic equations. We had to check for extraneous solutions when we were solving square root equations. Why do those three plus this one type of equation have the ability to generate extraneous solutions? Because those types of functions have domain restrictions. You can't take the square root of a negative number. You can't take log of anything other than a positive number. You can't divide by 0. And when we eliminate the structure that gives us our domain restrictions, we give the math the ability to produce answers that don't work. It's not that the math is broken. It's that you eliminated the thing that was restricting the domain. So your job at the very end of all of these rational equations is make sure your answers are allowed. What is the one number x can't be? You can say it louder, guys. 0. Since neither of my answers is x equals 0, we're good. They work. You're welcome to test them if you'd like to. 1 plus 3 over 1, that's 1 plus 3. It works. 3 plus 3 over 3, that's 3 plus 1. It works. Okay? Essentially, as long as it didn't make a denominator equal 0 and you're confident that your algebra was good, the answer works. Okay? Don't write large. I made the mistake of writing too large in period 1. You only have one fraction. That means you only have one denominator to worry about. You're going to distribute that denominator across the entire equation. So I have x times x minus 4 plus 1 times x minus 4 over x minus 4 Man, I did the same thing in period 1. I didn't need these parentheses down here. Well, whatever. They're not wrong. I just didn't mean to write them. And 0 times everything is 0. Did I need to write the plus 1? No, right? So why did I is the question. Let me show you why. I'm trying to help you avoid a very common student mistake. You see, oh, x minus 4 over x minus 4, that cancels. And what's the common student mistake right there? They do cancel. I did it in pen. What's the common student mistake? Yes, Trenton?
They don't break down the 1, they just leave it as 0.
They leave it as 0 and they don't call it 1. This is division. Anything divided by itself equals 1. So I put the 1 there to help you realize that there is something still here, even though we've canceled. Canceling via division leaves a 1, not a 0. Okay? Please don't do that. Of course, I will do that on my test, and calling that a 0, I'll have the wrong answer waiting for you. It'll be there. Just letting you know. Distribute, and what we get is x squared minus 4x plus 1 equals 0. And unfortunately, there are no two numbers that multiply to 1 that add to negative 4. So what are we going to have to do to solve for x? Quadratic formula. Quadratic formula. X equals negative b plus or minus root b squared minus 4ac all over 2a. Please know your quadratic formula. It's an Algebra 1 thing. And you could either sing to the tune of Row, Row, Row Your Boat or sing to the tune of Pop Goes the Weasel. Either way, you could make this a song. I'm not going to sing it though, because I wouldn't want anybody to sign me to a record deal because you'd lose your teacher. You know, so I got to keep my talents to myself sometimes. Let's work it out. I haven't written in orange enough today, so I'm going to go ahead and move over to orange. I haven't written it at all in your period. So we have x equals negative, your b value is negative 4, plus or minus root, there's your b squared, minus 4. A and c are both 1s. There. So 4 plus or minus the square root of 16 minus 4 all over 2. You have to be able to reduce radicals. Time to avoid a common student mistake. Another common student mistake that I'm seeing from you guys. A lot of people are dividing right here. You can't do that because there's a plus or minus symbol separating your terms. You can only be canceling things off the top and bottom if they're factors, meaning they're held together with multiplication dots. You can't do that. What you do have to do is reduce the square root of 12. What perfect square goes into 12? 4 does, goes in 3 times. So we have 4 plus or minus the square root of 4 times 3. We still have this over 2. Now 4 is a perfect square, so I'll be able to take its square root and bring it outside. Four plus or minus 2 root 3 over 2. Now you are allowed to divide by 2 because you can divide both things by 2. But Mr. M, they're held together with pluses and minuses. Why am I allowed to get away with that? Because if you wanted to, you could factor the numerator and you could say its GCF is 2. And you could bring a 2 on the outside. And on the outside of the parentheses, on the inside of the parentheses, you'd have a 2 plus or minus root 3. The 2 on the outside of the parentheses is now a factor. It would cancel the 2 on the bottom. Either way, you'd be left with 2 plus or minus root 3. Those are your two solutions. What's the only number x was not allowed to be? 4. Obviously, this is not 4. So we're good. I'm confident in our algebra, so both those answers are true. 2 plus the square root of 3 and 2 minus the square root of 3. Cool? Questions, comments, concerns before we move on to the more challenging questions? Nothing. Okay. We get a sip of water before we move on, so I'm going to pause it. Boop. We have 2 denominators. That means we're going to need to find the least common denominator so we can distribute that least common denominator across everything. From yesterday, if you're looking at this denominator, what's it jealous of? What does it want that the other denominator has? Just a minus 3? So I just write minus 3 on the top and bottom? What did we do yesterday, guys? X minus 3. Remember, you can only multiply to the top and bottom of a fraction. This denominator is missing the x minus 3. This denominator is missing the x as a multiplier. That means our least common denominator is x times x minus 3. So that is what I'm going to distribute across the entire equation. You never know. You might have a test question that just says, what's the least common denominator? It doesn't even make you do any work with it. Mr. M, is the least common denominator always just going to be me multiplying the 2 denominators? No. No, it's not. You saw that yesterday. So just be able to find least common denominator. I don't want to have to draw the distribution lines because they're going to go into my solving a rational equation title. But it's going to go to all 3 places. And you're going to be super duper careful because you see a minus sign between your 2 fractions. That may or may not come back to haunt us. Just realize that you could say this is a plus and call that a negative 2. You could do it that way. That way you know you're distributing a negative 2. But I'll leave that up to you. So let's see. Trying to pick a color. I'll just go back to blue. Blue feels good. So we're going to distribute these 2 things to this fraction. I've got the 1, which I didn't need to write, but I'm going to. Then I've got the x, and I've got the x minus 3. On the bottom, I still have an x. Minus 2, the x minus 3, and on the bottom, x minus 3. Equals 4, and then x minus 3. And as long as you found the least common denominator, after you cancel out, you'll have no more fractions. So these x's cancel, woot, no fraction. These x minus 3's cancel, woot, no fraction. So we're in good shape. And I don't even have to worry about distributing a negative 2 to anything because it's literally just negative 2x. So life is good. And here I'm not distributing anything either. It's just a 1. So this cleans up. Do x minus 3 minus 2x equals, and over here you might as well distribute your 4x. Oh, poop. That's right. That 4 is a 2. It doesn't work if it's a 4. Please make it a 2. I caught it much earlier this time than I did in first period. It's a 2, not a 4. I mean, we could do it with a 4, but we just have to use the quadratic formula again, and I really don't want to do that. Quadratic formula is not fun. But if we make it a 2, it'll factor. Sorry about that. Anyway, let's distribute our 2x. It will give us 2x squared minus 6x. We're clearly going to bring everything to one side. If you want to combine your like terms before you do that, be my guest. I don't really see a reason to. So what are we going to do? I'm going to subtract x from both sides. I'm going to add 2x to both sides. And I'm going to add 3 to both sides. And that results in this quadratic. 0 equals 2x squared. Now, minus x, let's see, so minus 6 minus 1, that gives me minus 7. Minus 7x plus 2x minus 5x. And then there's a plus 3 at the end. And as promised, this will factor. I think. What's not working right in my brain? Are the two numbers that multiply to 6 that add to negative 5? Yes, negative 3 and negative 2. Thank you. I'll be okay. I'll be all right. Caffeine's wearing off. So the answer is yes, it does factor. And since it does factor, you need to be able to factor it. Choose a method of your liking. If you want to split this minus 5x into a negative 2x and a negative 3x and factor by grouping, you can. If you want to use the Lizzie method, you can. If you want to use the guess and check method, you can. I don't care. You are Algebra 2 honors students. You need to be able to factor. So I'm just going to factor it using buku years of experience because I am old. Since they're multiplying to be a positive, I know both these things say minus. I know 1 is a 1 and 1 is a 3. And it's going to be the 3 here and the 1 here. Because negative 2 and negative 3 makes negative 5. Just like that. Now we just set both our pieces equal to 0 and we solve for x. This one's easy. Add 1 to both sides. Add 3. Divide by 2. And at the very end, your job. Make sure you haven't violated the domain of the original question. There are 2 values x cannot be. Those 2 values are x equals 0 and x equals 3. Neither one of those things has happened, so those are our 2 solutions. Any questions on it? Yes, sir. Why did I multiply the x minus 3? Wait, where? Here? Why am I multiplying the x minus 3 there? So because I'm not trying to write it as one fraction, I don't want to do it to the top and bottom. Let me approach the question a different way for you so that you can see, compare what we did yesterday with what we did today. What I was doing today was just trying to make it so I didn't have to look at any fractions at all. Okay? 1 over x. Oh, wait. I'll just write it, and then I'll scoot the paper up. Let's pretend we didn't have an equal sign and we weren't worried about the other side. Okay? If you wanted to write this as one fraction, what does the bottom of this fraction need? It needs an x minus 3. So if I'm trying to combine this into one fraction, then I'm multiplying the top and bottom by an x minus 3, just like we did yesterday. What does the bottom of this fraction need? An x. So we would have to multiply the top and the bottom by x, like that, right? Now here's what we would end up with. On top, I would have x minus 3 minus 2x. Yes? On bottom, I would have x times x minus 3. Cool with that? Originally, we had it set equal to 2. Now, if you wanted to have no fraction, all you would do is multiply both sides by the denominator, right? And you would get this. I'm aware I have like terms. I'm just not caring about them right now. Look familiar? So you could take the time to write it as one fraction, which would require you to multiply to the top and bottom of a fraction. That way you're not altering the value of the fraction. And then once you have one fraction, multiply both sides by whatever that denominator is. What we were doing was deciding what that denominator would have been and multiplying everything by that denominator. But when you multiply by a value, any fraction times a number. It's like if I said, I have the number 2/5 and I want to multiply that by 3. That's actually 3 over 1. So it's 6 over 5 because you're multiplying across the top and across the bottom. So we know that if we triple 2/5, we get 6/5. But if I multiplied this 3 to the top and the bottom, I would get 6 over 15, which reduces back down to 2/5. So multiplying a number to the top and the bottom is multiplying by 1, but it keeps your fraction. Multiplying by just the least common denominator is a strategy we use to eliminate all of our fractions. It doesn't matter which method you choose. Either do what we did yesterday, combine to a single fraction and then eliminate denominators, or distribute the least common denominator to get there. It's up to you. I just typically do it this way, honestly, so I can stop writing fraction bars. But they're equally correct methods, okay? My best friend down at Northport, when he teaches this, he teaches it this way. Because it's not that one is more correct than the other, it's just what you prefer. And I'm happy to show you both and say, if you are more comfortable doing it this way because you mastered yesterday's material, then do that. Just be good at it. And that's all I care about, is just being good at it. Because they're both equally correct methods. We ready to move on to things that could generate extraneous solutions? Yes, Mr. Rep. Fantastic. So here we go. How do I know that there's going to be extraneous solutions? Because I titled the question that. Is there a way to know just by looking at the equation? That's what somebody asked me in period 1. The answer is no. I mean, unless you're a super genius and you just instantly see all the algebra in your head, no. I don't know of a way of knowing if there are extraneous solutions. I don't know. I can tell you that recognizing patterns, I've started to notice when they happen most often. I've noticed that they happen most often when I have x's in the top and bottom of a single fraction. Is that the only time? No. Is that a guarantee? No. But I have noticed that they usually occur when there's an x in the top and the bottom of a single fraction. So if you look at our first 3 examples, none of them have x's in the top and bottom of one fraction. So what I just told you was just a hint. It's not a rule, it's not a law, it's just a pattern that I have noticed. And for all I know, that pattern is completely bunk. It just tells me be on the lookout. The moment I see x's at the bottom of the fraction, I'm instantly on the lookout anyway. Alrighty, let's go. Just like yesterday, we're going to need to figure out what that least common denominator is. That means we need to factor everything. That factors. In fact, the 2 numbers that multiply to 3 that add to -4 are -1 and -3. They're right there. Is this denominator missing anything? Is it jealous of anybody? No. If the answer is no, that means that is your least common denominator. The moment you have a denominator that you can say it's not missing anything, that is the least common denominator. So since it misses nothing, that's the least common denominator. That is what I'm going to distribute across all 3 things. You know what would be great is if you could skip over writing this line. If you could skip over seeing that and instead see it in your head. Imagine these 2 things are now sitting on top of this fraction. What's going to cancel out? the x minus 1s will cancel out. So what's left up there is a 2x and an x minus 3. Imagine these two things are on top of this fraction. What's going to cancel out? X minus 3. All that's left is that 1 and the x minus 1. And if you put these two things on top of this fraction, because that is the least common denominator, I hope it's obvious that they'll cancel each other off, the top and bottom, and all that's left is a 2. Got to distribute here, technically here, but you distribute a 1 and nothing's going to change. So I'm just going to basically drop the parentheses and write x minus 1. So let's distribute. It gets me a 2x squared minus 6x. And if you quote unquote distribute here, it gets you a plus x, a minus 1, and all that equals 2. You want to combine like terms and get it all to one side. I like my x squareds to stay positive. So because of that, I'm going to subtract a 2 from both sides. So I'll have a 0 over here, and my like terms are right there. That gives me 2x squared minus 5x, because negative 6 plus 1 is negative 5, minus 3 equals 0. So it's remarkably similar to the last question, but the last quadratic was a plus 3 at the end instead of a minus 3. That's the only difference. So we have to ask ourselves, are there two numbers that multiply to negative 6 that add to negative 5? Yes, there is. And they're not 2 and 3. Don't fall into that trap. The two numbers that multiply to negative 6 that add to negative 5 are negative 6 and positive 1. But because there's a number in front of x squared, I can't just write x minus 6 and x plus 1. That would be wrong. I don't think I've written in enough green today, so I'll do the rest of this question in green. It factors to something like this. Oops. Now we know the two things at the end have to multiply to a negative 3. That means one is positive and one is negative. And I know I'm going to have to get a minus 5x. So it's going to give me a positive 1x and a negative 6x, just like that. Again, find a factoring method that you're good at and stick to it. For me, it's enough to say I see that it does factor and I know how to start it, and I can quickly go through the guess and check process in my head to see which one was the plus, which one was the minus, which one was the 1, which one was the 3. So now you set your parts equal to 0. This one's easy. It gets you x equals 3. Here, subtract 1, divide by 2. My two solutions. Are they both allowed? No. Which one's not allowed? X equals 3 is extraneous then, because if I try to use x equals 3, I'm going to get a 0 on the bottom of this fraction. So big fat no, goodbye x equals 3. You are wrong. However, x equals negative 1/2 is correct. Yay, math. What do you think? Finding least common denominator, distributing it, and eliminating, solving quadratics. Not bad? Right? Not bad at all? Okay. Okay. Last one, because I don't feel like doing the word problems. I didn't put any on the homework. I shouldn't even bother putting it in the notes. We're going to factor everything that we can factor. That right there, x squared plus 2x, it factors. It is the GCF of x. This denominator is missing an x plus 2. This denominator is missing an x. This denominator is missing nothing. Since this denominator is missing nothing that other things have, this is the least common denominator, x times x plus 2. So that is what we're going to choose to distribute across our entire function, or our entire equation, I should say, so we can eliminate all fractions. Goodbye, fractions. And I want to do it the same way I did the last one. We'll talk about, like, imagine you did the distribution. Imagine you put these two things on the top of this fraction. What would cancel out? These two are now up here. What cancels out off the top and bottom? X does. So what's left is this x minus 3 and this x plus 2. Now we imagine this x and the x plus 2 are on top of this fraction. What cancels? X plus 2's. All that's left here is a 3 and an x. And if you put these two red things on the top of this fraction, both the x's and the x plus 2's cancel, and all that's left is a 6. Distribution. Do the foiling process right there. X squared. Negative 3 and 2 adds to negative 1. Negative 3 and 2 multiplies to negative 6. Wait a minute. Negative 6 and positive 6 cancel each other. When I combine my like terms, negative 1x and positive 3x gives me positive 2x. And yeah, that factors. GCF, right? So what are our two solutions? For this one, x equals 0. For this one, x equals negative 2. Are they both allowed? No. Which one's allowed? Oh, neither. Crap, look at that. I can't use x equals 0 and I can't use x equals negative 2. These are both extraneous. So what does that tell us? No solutions. And you know what? I knew that there was no solutions on this line right here. But why? Was it because I factored in my head? No. It's because this is one of my three denominators. It's right there. No denominator is allowed to equal 0. This is a big fat no-no. And because that's not allowed, we could have stopped there and be like, oh, no solutions. But, you know, it's okay. Because it's always worth doing the math just to check. And I have lost my nerd sign. Oh, here, I put it away. Anyway, there it is. Thanks, nerds.